Our tutorial, Developing Production-Ready NATS Applications. This is Waldemar Quevedo, engineer at Synadia and NATS maintainer. I'm Colin Sullivan, product manager in NATS. And can I just really quickly get a show of hands? Who's using NATS today? Oh, good, good, okay. What about in production? Good, about the same number of hands. That's great, that's great. So, before we start, you guys know a lot about messaging, or a fair amount, but let's talk about some general messaging features and why we need messaging. So messaging, deploying and developing applications in distributed systems, it's hard, it's complex and difficult. And all message-oriented middleware vendors, like NATS, they provide a basic set of features to make this easier. Not every vendor provides all these features, but in general, they'll provide things like multiple messaging patterns bundled together in one tech, location transparency, the decoupling of data producers and consumers. I don't need to know exactly where my data producers are as a consumer. As a producer, I don't need to know where my consumers are, and I don't even have to know who sent the message. And also, built-in load balancing is a feature as well, and that is extremely important in cloud deployments. So what is NATS? NATS is an 8-year-old production-proven cloud-native messaging system. We made NATS for developers and operators who just want to do their jobs, who don't want to have to spend time worrying about how to do messaging or how to deploy messaging. Our DNA is performance, simplicity, security, and availability, and NATS is built from the ground up to be cloud-native. Its first use case was the underpinnings of Cloud Foundry. We offer multiple qualities of service, at most once, at least once with streaming, support for multiple communication patterns, and over 30 client languages. NATS was created by Derek Collison, and Derek's been solving the really hard messaging problems for over 25 years. He was SVP and Chief Architect at TIBCO, Technical Director at Google. He architected Cloud Foundry, CTO and Chief Architect at VMware. He founded and was CEO at Apsera, and now is currently founder and CEO at Synadia, where many of the NATS maintainers are. Derek's built a highly experienced messaging team around NATS, and we've built an engaged user community. I mean, I'm hoping after KubeCon we'll break 1,000 Slack users. So, a quick bit before we dive into the tutorial about message patterns. NATS supports 3 message patterns: publish, subscribe, load balance queue subscribers, and request reply. Before that, we need to understand a little bit about subjects. All a subject is it's simply a string representing interest in data. It's what you publish to, it's what you subscribe on. So a simple subject is foo, and you can tokenize the subject hierarchically, so you can have foo.bar. And then what you can do is add wildcard subscriptions. So you've got a star, which matches 1 token, or greater than, which matches everything beyond where you specify greater than in the subject. So for example, foo.star matches foo.bar and foo.baz. Foo.star.bar will match foo.a.bar, foo.b.bar, and foo.greater than will match any of the above. And you can use greater than, which matches anything running through the NATS system. We have a publish subscribe pattern. And this is your radio station. This is where subscribers subscribe to a subject, and anybody publishing on that subject gets it. So think of it like a radio station where you turn your dial and you're listening to that subject. You'll get those messages. This is used for high fan out or specialization or parallelization of work. So for example, a publisher might publish sensor data on a subject. One subscriber might log that data. Another subscriber might update a UI. A third subscriber might check it and generate alerts. We've got a load balance queue pattern. So this is similar to the pub sub, except that what happens is when the server gets a message, you've got subscribers that you've told to belong to a group. And any subscriber in this group can receive the message, but the message will go to only one subscriber, effectively load balancing. So if you publish messages 1, 2, and 3 in this diagram here, you'll see that the different subscribers in the group can get this message. This is used for load balancing, for auto scaling, and for lame duck mode during upgrades. So it's a very smooth transition as you move from one application instance to another. And then we have a request reply. This is your conversation. This is your phone call. You request to one replier and get a message back. But underneath the hood, everything in NATS is a subject. So we've offered some optimizations here. You can request to many and tell the server, I only want one response back. Many repliers will respond. The server will get the first response back and short circuit. It will prevent the other responses from filtering through. And this is a great way to get an extremely low latency response from many repliers. Or you can respond with queue subscribers to load balance. So quickly going back, here's your queue subscribers, and the messages are going to be randomly distributed amongst the subscribers. If you add this in a request reply scenario, you can have many repliers that are queue subscribers, and they'll handle requests, and randomly these requests will be distributed evenly, generally evenly, amongst the subscribers, giving you an improved quality of service. Or, improved latency and improved response times. Along with that, we've added drain mode. So supported clients provide a drain mode to allow graceful shutdown. So remember, with queue subscribers, I mentioned you can use that for lame duck mode or upgrades. Now clients can just issue, instead of closing a connection, draining a connection. They stop listening, stop subscribing, and handle all the buffered messages that they may have received in the meantime. So this provides you a very graceful shutdown to eliminate data loss, allows you to smoothly downward scale, and it's great, again, for upgrades. We also have in the server auto-discovery. So we've built NATS to be extremely resilient and low config. So in the cloud, this is very important. What happens is you have a NATS cluster up and running. You can add a NATS server and direct it to point it to any one of the other servers in the cluster, and they exchange topology information. So the servers will talk to each other saying, hey, I've got a new server, or hey, I've lost a server. Here's what the topology looks like now. It goes further. The servers can send these to the clients, and the clients get updated topology information about the server cluster. And this is great for failover. That means a client can fail over to a server it never even originally knew about. And it's great for rolling upgrades in case you need to upgrade your NAT servers. So now I'm going to hand it over to Wally. He's going to go through the tutorial, our NIFT service.
Okay, the core of this tutorial is we're going to show you how to is architected and developed one application named NIFT, which is kind of like a clone of like a Lyft or like basically a ride-sharing service, but using NATS. So we're going to show you some of the newest features that are part of the server and also from the clients. And also one question is like, how many of you have like Minikube installed? And okay, and the basically Go installed in the, okay. Yeah, so there is a public repository here, what is it? If you want to clone it and follow along, there are two branches. One is the complete version of the repository, but by default, you're going to be cloning the tutorial branch. So I can give you some time to clone if you want to try. And we'll be browsing some of the code to learn some of what are the best practices of what I've been so far successful in applications that are using NATS. I've been using NATS for over 5 years already. I've seen it like started with Cloud Foundry, or at that point was still on Ruby, and also very advanced control plane usage as part of the Apsera platform, where we're using the Go version of the server and the Go client, and that helped me to learn what are some of the techniques that work really well for NATS. And I'll be sharing some of those lessons in this talk. So basically, it's like WallyQS, my GitHub repo, KubeCon -NATS 2018 tutorial. And also wrote a book on NATS. We're going to be giving away copies at KubeCon if you stand swing by our booth. Has anyone got the practical NATS book already? Okay, nice, thank you. So yeah, we have many copies of this book if you want to get your hands on it. And some of these materials, this kind of also covers newer features that are not part of the NATS server. We probably next year we need a new edition of the book. So this is more recent material than the book. Okay, so on a high level, this is the architecture from the service. This is kind of like the classic NATS microservices architecture, where you have an API server that speaks in HTTP. The clients will be connecting to this HTTP front end. Then, but behind the scenes, all the communication is internal communication is happening over NATS. So we have a set of a layer of nodes that are going to be called the NATS, the NIFT service, and that is basically the point where you start using PubSub to make requests to find an available driver. So in the example application that I have shared in the repo, you can send a request to find a driver that is going to pick you up, right? Other features are left as a exercise to the reader. So we're going to cover how that request response flow works and where to use some of the messaging patterns that Colin previously mentioned. And so, is everyone okay with the repo? Okay. So yeah, this is the architecture. It's an API server. It's a REST API that will receive a request. And we're going to add some discovery subjects as well. And there's going to be an agent installed that could be, for example, in a car that are going to, so that they can be discovered to accept requests. And the core of it is the NIFT service that is going to be the load balanced service that the API service is connecting to find an available driver. I'll go to the repo already. Okay, start sharing code. Hope this is okay. This is okay? I think so. So another thing is that we're going to be using some of the latest features from NATS. So try to make a go-get to the GNATSD and get what's available in master. For the Kubernetes, I've prepared some edge images that we can use. Okay, so when developing the application, one thing where I like to start is by creating a component reusable library where that all of the other components from the service are going to be importing, and that is where we are going to be centralizing some of the how we customize the NATS connection, and then adding some default subjects that are helpful, for example, for discovery within the microservice. And so that you can have some, so that you can define some default behavior for anyone that's part of this service. And in this case, I created a component struct to identify each one of the components from the service. I'm going to label them with an ID, which is going to be, in this case, a NATS unique identifier. So we, as part of the NATS project, we have our own library for generating very fast, efficient unique identifiers. And this is one of the mechanisms that is used for the request response. So we're just using this library once again to generate, label each one of the components with a unique identity, just for, instead of a UUID, for example. So we are going to label each one of the components with its own ID using a NUID. And each one of the components can have a different behavior. So we're also just label which kind of component they are going to be. This could be, in this case, in case of this tutorial, it could be an API server, or it's going to be the NIFT service, or a NIFT agent that's going to be receiving the request. Some of this is boilerplate for setting up logging and tracing the PID. Generating the unique ID, as we are using NUID. And this is part of the NATS.io organization. So the first thing I want to share is how do we customize the NATS connection. So we use the one pattern that is very popular for Go libraries that is used. It's called the friendly on-function options, basically. So when you are defining a NATS connection with NATS Connect, the API tells you that the first parameter is a list of the servers. It could be a comma-separated list, but it also could just be a very simple domain. Is going to default for example, we could make it connect to the demo endpoint. And just setting demo.nats.io is going to connect it into the publicly available endpoint that we have. And it's going to default to 4222. If you want to establish a TLS connection, you can also just define TLS as the scheme. In this case, I think it's 433, it's 443. And that would basically start a TLS secure connection against the server. In this case, we are plumbing through the list of servers in each one of these components, and the rest is the variadic list of options that we're going to use to customize the server. Something that's really useful to do is to set a name for the connection, so you can label your connection. And that is going to be very helpful for monitoring purposes, because then you can pull the monitoring endpoint for the server, which is H222 by default, and list, for example, based on that, not only the connection ID that you have, but using that label to quickly identify in the JSON blob that the server returns to you, which are the in and out messages and bytes per second. From this connection, the list of subscriptions, for example. So in this case, where they have a list of NATS options, so I'm just going to pass it here. It's a production-ready application, so always check your errors. So yeah. Very simple, just setting a list of options. So now let's use it, for example, in as part of the main from one of the components. Let's start the API server. Also some boilerplate code for setting up the version for setting explicitly what is the NATS server that is going to be connecting this component. So we can skip this. Here we are starting to use the component library. So I made a constructor where we can just pass it a string, and this is going to set which kind of component this server is. Signal handler, I'll go into that later. Some basic login. And so here we are establishing a connection by default, which is using the default parameters from NATS. But for example, here we could now set our own customizations. Let's say, for example, let's say that NATS reconnects. We're going to set it to 5. And this is just going to be plumbed through the NATS as part of the variadic options from the NATS Connect. So I found this way of using the NATS Connect API helpful. And it is important to be able to allow how to customize the NAT connection to NATS per component. Because, for example, let's say that, back to the architecture. So these layers of nodes are going to be running in a cloud, let's say one of the Kubernetes cloud providers that we have right now. But the agents are going to be running in all the agents, I mean, the drivers, right? So in case of this layer of nodes, we want them to eventually stop reconnecting and maybe exit. But in case of some of the agent nodes, we just want them to continue to retry and never give up trying to connect to NATS. So in that case, let's check how can we do this differently for the agent. So this is the agent. And we are also using a list of options for customize the connection just for this one. And in this case, we're going to set it so that it never stops reconnecting to NATS. And you can express that in the client by setting it to -1. That is going to be basically endlessly reconnecting to NATS. We can also modify further the reconnection logic. Reconnect time wait to, let's say, 5 seconds. So now the way that this component handles the NATS connection is quite a bit different. You can make it case by case. So another very important thing for NATS applications and that you definitely have to implement for a production scenario is are the event callbacks. The event callbacks are called whenever there is the client changes state from being connected to being disconnected. Closed is a terminal state, so if the client ever reaches the closed state, it will never try to reconnect once again. So at that point, you have to recreate the NATS connection, and you cannot continue using the built-in reconnection logic that the clients have. And there's also the discovered handler for the case where you have new nodes joining the cluster, and then the new IP port from that node is gossiped. All the client advertise that you have set from that server. So that way you can trace whether new nodes whether this client in particular is perceiving these new nodes that are joining the cluster. So I'll go one by one setting this. First I'm going to set the reconnect handler. This is a NATS connection. And let's say that we're going to log that has reconnected. Has reconnected to, well, you can use the state from the connection that is closed over here. Okay, so this way you can identify to which server the client reconnected to. So let me try that real quick. First, let's start the NATS server. I'm going to start it in. So -m port 8222 is for the monitoring port. And the screen below, I'm going to have a NATS stop, which is a utility that you can use to check the clients that are connected in some of the state from the server. I'm going to check whether okay, so we have the API server should be connecting. And we can see now that's part of the data that the monitoring endpoint sends back to the client is that we have a component named the API server, and it's uniquely identified by this IP, by this label, which is the unique, the NUID. So let's start another component. Okay, have a new component joining the cluster. And let's reconnect. For the agent. Max reconnects. And this one is reconnect wait. We need the time. Time seconds, agent. Where is it? 57, sorry. Oh, yeah, thank you. Should Go imports should be doing this. Okay. Okay, not sure why Go font didn't get it. Okay, so we have the new component join the cluster, and we can know what is the mapping to the connection ID and via the monitoring endpoint. And let's now kill the server and restart it. We should see now that the client's the log to which a component it is reconnecting. So in this case, we only have a single node cluster. But by default, it is if you have a multiple nodes cluster, then it's going to try to randomly reconnect to another one in the pool. Okay. So far, any questions? You can raise your hand. Just let me know. Okay, so customizing the reconnection logic per component. Then we can set the disconnected handler. For when you disconnect. Disconnected from NATS. Then, and let's leave it at the closed handler as well. Okay. So now if I leave the server shuts down for too long, the clients will try to reconnect. The reconnection attempts, they are not logged as part of handlers, only when you reconnect. So eventually they will run into the closed connection. And if we want to, for example, we could say that whenever you disconnect from the server, just terminate this process and exit. Exit one. Then you can let Kubernetes or well, your cloud handle how restarting to another node, for example. So event handlers are very important for applications. And let's move to defining some of the behavior from the system. In this case, we'll start with the API server that is going to be receiving the requests. I made a small tool that sends a request to this service to try to find a driver. And right now, it is not receiving any response back. So it's failing. Also important when using NATS in the, so for NATS, the payload is opaque. And so whenever you publish a message into NATS, it's just that blob of bytes. And NATS doesn't transform that data. And it doesn't do any transformation to that data. So in case you want to have something like a request ID identifier and investigate across multiple components how that request is being handled. And for example purposes, you can also continue to use the fast NATS identifiers. So in this case, as part of the agent request type, I added a requested ID field that is going to uniquely label each one of the requests that are sent to the API server, and then these request IDs pass through all the components and as it hops around from component to component. Now, then if you collect all of the logs together, you can see that, well, this is the history from this request and where up to which point it failed. So NATS won't do this for you, so you have to, on your own, define the request ID for the requests. So let's. Yeah, just a string. In this case, just a string. You can pass it in with a trace ID from ALE. Yeah, you can just reuse any request ID. For example, if you already have some request ID from the HTTP framework that you have, then you can just continue to reuse that and set it here when you're handling the request. Yes. That's all up to the client, yeah. We can see that, for example, we follow the protocol. Allow subscribing to anything. For the server, everything is just an array of a slice of bytes, and doesn't. Well. Right now, it is not publishing. We have to implement. Yeah, but yeah, it's essentially just bytes. It doesn't do anything else. OK, so let's send the requests. We set identifier for each one of the requests, and in case that marshalling error fails somehow, then we fail there. And here is where we are going to sending the request to the layer of NATS nodes where, well, the clients that can handle finding requests. So the API server responsibility, it is just to call this other NATS API internally to find an available driver. And it is that way, well, this is good to be able to separate the concerns of scaling up that behavior. For example, then you can use the queue subscriptions that we're going to use for as the in the component that is going to be receiving this request. So yeah, here we are making the request into the drivers.find subject. We're going to give up after 5 seconds. If that doesn't fail, then we log that this request failed. So now let's go to the application and define the queue subscription that is going to be processing this. We're using a queue subscription here so that you can, each one of the components of this type are going to be randomly balance one of the requests. So that way, well, you can load balance the work among all the components on that layer. So let's go to NATS. NATS queue subscribe. Drivers.find. Using manager group. And the function that is going to be handling this is here. Actually, just return error. So whenever the API server sends this request to the drivers.find subject, this NIFT service is going to receive the request and then try to look up for another agent available for to handle this request. So the next step is to define this drivers.write subject that is going to be created by the agents. So let's go to the agents. Well, in case I already had it here. We're using here an asynchronous subscription on the drivers.write subject. This is not a queue subscription, so all of the agent components are going to be receiving these requests, and then they're going to decide whether to accept it, depending on some condition. In this case, have it implemented so that each one of the requests you can specify the type of vehicle that you want for this particular write. So in case an agent has a small car, then they can just defer and they can just yield and not reply to that request. And also, just to simulate some latency among the nodes, I added some delay to reply in this request. This is an asynchronous subscription, and something important to highlight here is that internally, the agents are going to be receiving all the requests, but they're going to be handling them sequentially. So in case one of these responses takes longer than takes very long, then it's going to block the rest of the requests. We can simulate that, for example, to sending a lot of traffic. And you can see that, you will see in the logs that some of the responses are going to be, well, I need to restart them.
How's ordering handled in server? Is it like partitioned by subjects?
Which one?
Ordering guarantees?
So the question was, how's ordering handled in the server? Do you want to handle it, Wally, or should I?
Just go ahead.
Oh, sure. It's source order delivery by subject. So if one producer is producing on foo, you're guaranteed that messages from that producer, on the consumer side, you're guaranteed that messages from that producer will arrive in order. Now, if you have two producers on foo and one subscriber, those messages might be interlaced. You just simply can't predict that, right? But yeah, source order delivery guarantees.
Well, and then, sorry, because of the sort of fluid subject partition thing, is it kind of, it's always sort of the full subject. So like you can do a ordering on something.star or whatever.
Yeah, I'm going to rephrase your question. The question was, does ordering change on wildcards? Is that fair? Yeah. So even at that, you will still get source order delivery by the publisher as a wildcard. So let's say you've subscribed to foo.greater than, and somebody's published to foo.bar and foo.baz. You will get the messages on foo.bar in order and the messages in foo.baz in order, but not necessarily the exact order the server processed it, depending if they go through routes, that sort of stuff. But again, source order delivery. That's sure.
Okay, this service. Send connection to the server. Yeah, I have a register here. Sending request. Yeah, I'm getting a bad connection error here. Let me see this. It's the agent. I'm chasing something, sorry.
In the meantime, are there any other questions anyone has as we've gone along? Oh, yes. We don't. So the question was, do we support MQTT? Not right now. Our plans sometime in 2019 is to provide actually tightly integrated support for MQTT. We realize how ubiquitous it is, and also how NATS being so lightweight works really well on the edge. So we are going to build something with MQTT, some bridge, or actually we're really looking at native support inside the NAT server. Oh, yes.
So I've tested NATS and I've tested the NAT streaming server. When I last tested it a few months ago, when I last tested streaming, you didn't support wildcards and streaming. Is that going to be something that's available?
Okay, the question was, will wildcards be available in NAT streaming? Yeah, they aren't available today. We're looking at, internally we call it Project Jetstream. It's NAT streaming version 2. And we're looking at wildcard support there. A lot of people have asked for that, and so we're adding it. Sure.
Sorry, this is kind of
No worries.
yeah, I'm not familiar with the streaming thing, but does that cover like stateful aggregation as well as stateless topology?
Yeah, the question was, does NAT streaming cover stateful aggregations as well as stateful topology? Or stateless? Yeah, NAT streaming, so just taking a step back, NAT streaming is actually a layer atop core NATs. What Wally's demonstrating here is what we call core NATs. This is your fire and forget. If you lose a message, well, your application has to retry. That does sound fragile, but if you think about it, that's how the internet works today. But then on top of core NATS, we have NAT streaming, which gives you at least once messaging guarantees. So you're guaranteed to get your message, and if things go really bad, you lose network connectivity, you come up, there's a chance you might get the same message again. But what NAT streaming does is it allows you to replay data by time, give me the last hour's worth of data, by sequence number, my last sequence number is 500, or give me everything from sequence number 250 back, and you're able to get the sequence numbers for messages in NAT streaming. And then, or last value cache, right? My application comes up, I need to know what was the last thing sent. So NAT streaming does give you all of those. One other thing it gives you is durable subscribers. And what durable subscribers are it's a subscription where if something bad happens, you have a network partition, whenever it's repaired, it just picks up exactly where it left off. There are a few other things we can go into more detail, but that's a general gist. Yes? Okay.
I mean, there are different reasons why there's an ecosystem of these things. I'm just trying to pick the right tool for the job.
Right. So the question was, is there a white paper comparison of, products in this that we can recommend? You're asking me to recommend something other than NATS, really? I'm teasing. Yeah. So. Right. The different messaging solutions provide different tool sets, if you will. So while something like AMQP won't be a Swiss Army knife, it does a lot of things. NATS is more of a scalpel. It does a few things very, very well, or more than a few. But it does a subset of things extremely well. That's tailored for the cloud and edge and IoT. But as far as a comparison goes, Tyler Treat has written some blog posts with performance comparisons. And in fact, with CNCF in the TOC, we did a small matrix with comparison of features. But generally, when people ask, we really prefer third parties to give their advice because, I'll be as honest as I can, but yeah, I'm a bit biased.
Okay, sorry about that. I found the bug that I had here.
Yes?
Yeah, so my experience so far with NATS using it with different clients is that based on callbacks, but with the callbacks functions that you're able to when you create a subscription, you can't say from what I've seen, there wasn't a way I could say just consume one message. Is there any support for something like that? That the just consume
Yeah, there's a couple things you can do there, and it depends on the client. But in most clients, you could actually unsubscribe from within the callback. So you receive your message, and then you unsubscribe, and then you're done. The other option is to do a synchronous subscriber. So then you create your subscription, you wait for a message, and you actually block until the message is received, and then you unsubscribe. Did that answer your question? Okay, sure. Yes?
For the, not necessarily streaming, but for the core NATS, scalability perspective, what have you guys seen for clients and how many, what's the optimal number of nodes to run, something just general scalability studies or anything?
So the question was, are there any general scalability recommendations for NATS? This is one of these areas where it really, really varies on your network, your bandwidth, throughput. We've had a user with a cluster of 4 NAT servers able to query 50,000 nodes and get responses back in about 2 seconds, in less than 2 seconds. In fact, I think it's less than 1 now. We have some just extremely large NATS users, but again, it's really up to your use case and your mileage will vary.
Do wildcards
The question was, do wildcards have an effect on the efficiency of the server? Minimally, just minimally. We use some level 1 caching techniques inside the server to make that subject routing extremely fast. So wildcards won't have a whole lot of effect. The things that will affect the NAT server is the sheer number of connections and subscribers, and that's where you want to look at scaling. Subscribers affect memory more than anything else. Connections, naturally that's a function of the instance you're on, how many you can handle. Also, if you're using TLS, TLS is very CPU intensive, particularly bidirectional TLS. So you have to watch out for thundering herd problems. We've actually implemented timeouts that allow you to avoid this, but if you've got 10,000 TLS connections happening at the same time, you're going to chew up your CPU. Yes?
How geographically dispersed can you stretch a cluster? Something I could do and have a node in each geo and make a cluster, or how is?
So the question is, how geographically dispersed can we make NATs? This is a great question because as the NATs maintainers, we've been working on NATs to actually solve this problem for Synadia. And at Synadia, we're offering a global service. So we've worked a lot with NATs to provide a concept of superclusters, which are clusters of clusters connected together that use spline-based connection, spline-based connection routing, and some things like optimistic sends to really create a resilient yet easy on WAN traffic solution. So that's a lot of that's actually in master branch right now, today, and that'll be released, very soon.
Yep. Okay, so when it works, so just want to show real quick how it. Now you can trace the flow from a request across the components. In this case, we're looking for an agent that has the regular vehicle, so you can see tracing using the NUIDs across the components, which one, how long it took the request. And all this code is in this repo, and then sorry, it took some time here. So the next thing I want to show is how to deploy all of this in Kubernetes using the NATS operator, Prometheus, sidecars, and how many of you are already using Kubernetes in production? Okay, and are you using the operator, the NATS operator? Okay, so one is using it. So I'll just give a quick demo of the example of how to deploy on Kubernetes NATS using the operator. So here we have already the, let's delete the cluster. Here we already have a cluster running. So let me, this is the result from running this manifest. Here we're using an edge version of the server. You can enable Prometheus sidecar for attach it to each one of the clusters by using enable metrics. And we have this also Prometheus NATS exporter that is going to be polling from the monitoring endpoint and then feeding into Prometheus all the data. So let's deploy Prometheus. And that's Prometheus. And let's deploy also some of the cluster nodes. So let me delete this NATS cluster. And you can see that it's going to be recreated. By the operator, you can see that there's are two ready containers. One of the sidecar, one is the NAT server. NATS cluster. And then let's deploy the agents from this service. First, I'm going to deploy the service itself. Then the agents. This one. Okay. And we have a Grafana deployment here. So you can already use the dashboard. Copy. Need to so you can see the traffic from the servers in this cluster. And I'll open a port directly into one of the NATS servers to generate load. Let's take this one. I will send a request to the local port. Handling connection, okay. Where's it? So now these requests are flowing through the NAS cluster that we have in Kubernetes and feeding through the Prometheus dashboards by using the sidecars that were deployed by the operator. And also another thing that is helping with the deployment of NATS in Kubernetes, the operator helps you to form the cluster, and also you can just add a field with the certificates for a TLS secret, and then it will create the mount the values for you, for example. And just
I'm just an older version of the operator, and it was limited to only seeing things that contain some namespace. That were not operator for namespace. Is that still the case, or is that?
no, yeah, that's currently still the case in master. Yeah, but I think it's a good feature. We're looking into it. Probably something maybe in January we'll have a new version that we have addressed that issue. And yeah, so right now it is only going to monitoring creating clusters within the default namespace. So you have to create right now an operator per namespace. If that, some people really like that, but for others would like the flexibility of having a single operator being able to monitor all the nodes across namespaces. So that's coming soon. And I want to show some of the something that is okay. So this is within Kubernetes, and I think there's still time to show some of the accounts functionality that we have in the latest versions from the servers. So one of the biggest features that the server has is that you can now define multiple accounts to be able to have for better suited for multi-tenancy use cases. So I'm going to show you how this looks. So in this case, we have a new stanza within the NATS configuration where you can define multiple accounts. In this case, we're going to have 3 different accounts. One is for the clients that are connecting to the service. Another one for the NAT service, the NIFT service that is the queue subscription receiving the requests. So this is, for example, the NIFT service account. And if you remember from the example, we have a drivers.find subject. That is the one that's being load balanced with a queue subscription. In this case, we have defined a NIFT service account where we say that, okay, from this account, we are going to export this drivers.find subject. And then all of the users that are within this account, in this case, there's only one user named the manager version. And also, another good practice is instead of using user and pass, if you use user and password, you should decrypt your password. So we can get rid of this pass credential, and then in your part of your configuration, you can have the decrypted version of it. So in this NIFT service account, we have an export that is for the drivers.find subject. And it also relies on a couple of imports, well, one import from another account named the agents. So all the agents and the drivers are going to be on this agents account. And they're going to be accepting requests on this drivers.writes subject. And then from the NIFT agents account, we'll have a service exported named drivers.write, so that way they can reply back to the requests. And this the other account is the customers one. That is going to be importing from the NIFT service the drivers.find subject into its account, and has a couple of users, one for the API, another for example, a generic client. So let's start the server in this mode, so to show how it looks. Okay, so now we have the latest version from the server using the multi-tenancy features for segregating accounts and the subjects into multiple users, and we're going to make our requests. Once again, I need to start the components. You can specify the user as part of the URI. Where's it? It's the API server. It's the service. So this feature is really good to be able to control what are the actions that each one of the components can do within the service. For example, here I have the wrong credentials, should be manager. Okay, so now sending a request with this setup from the server, you will see that in the logs, things look a bit different. So this is how it looks when the server is essentially sharing data from an account to an account. That's how the importing and service functionality do. The sharing between the accounts is anonymous. So in the native implementation, the clients for the request response uses the ephemeral inboxes and subscriptions for doing the request response. So locally for an account, it looks like this. But as it traverses that into different accounts, it becomes transformed in order to keep all the request response anonymous between the accounts, so that you cannot trace a certain subject. So all the objects are now ephemeral in between the accounts. Any questions on this one? There's around accounts or data sharing? Yeah.
So if you set that up,
Yeah.
for the exports, right?
Yeah.
Once you do that, that topic can only be subscribed with that username and password.
Yeah.
Yeah, at a higher level, accounts are a great way to take a large deployment of NATS, globally even, and put users and really policy into different buckets. So from an enterprise perspective, you can set up a number of accounts. One, let's take a traditional sales and support and something else, right? What you can do is each of these accounts have their own namespace. So if you have somebody publishing in the sales account on Foo and somebody publishing in the support account on Foo, those messages will never cross. But if you explicitly export them and import them, then they cross. And what this allows you to do is to manage accounts separately, and you've decentralized management of some of this stuff from a NATS perspective. Although you may have different organizations in your enterprise managing their own accounts, only when the two accounts agree can data flow.
So this is a quick overview of what we did, the accounts. We basically separated into three different accounts depending on the behaviors, three different components. And so this way, for example, we can add users that are agents that can accept the request to basically the driver's agents in the applications. And all of those permissions are pertain to that account, and you can't mitigate. For example, being able to act as a service, for example. And so just to summarize so far some of the practices I've shown. It's really important for NATS, the reconnection logic, it's really helpful, but it's also helpful to debug how it's, to check the stability of the connection to NATS by using the event handlers. And a really good feature from NATS is the queue subscribers, and so that really helps for doing the load balancing, which is in a very simple way, and allows you to keep things simple. There is a drain as well that I forgot to cover. There is so when we have as part of the component, I define this shutdown method. And there are two ways for detaching from NATS. One is to abruptly closing the connection, and that is the close API. In this case, let's say NATS connection close. So what this will do is that it will any pending data that was from the client at that point is going to be flushed into the socket and then close the connection without waiting any further. But in this case, if there might be some requests in flight within this system, it is more graceful if you process all the pending requests that you already have in flight and they were delivered to you before detaching from the system. So for that, there's a new API in the client's called drain. that will basically first unsubscribe you from all the topics that you were registered, and then internally in the client dispatch all the callbacks with the pending messages that you had and process them, and once you are done, flush any remaining publishing data and closing the connection. So it also leaves you at the closing state from the server. This is a good practice to be able to more gracefully process the requests while upgrading, for example, a version of the components. And bcrypt for passwords is also, we have a new feature as well named NKeys, that it's you can use it instead of bcrypt and password, so you can drop by the demo and by the booth at Synadia, and we can show you some of that. Clustering for fault tolerance, so the operator helps a lot in Kubernetes if you have a Kubernetes-based deployment. And the new feature for the accounts really help you simplify some the isolating the permissions and the users. And also a TLS. There might not be enough time here to cover it, but it's in the repository. We can try to show, well, there are two TLS configurations that you need to think about. There is actually three with the latest version from the server. You have to establish TLS for the clients, and also you have to set up TLS for the internal routing from the NATS cluster. And there's also the superclusters functionality that we have to the gateways. It's also another port and also endpoint that you have to secure. And in this case,
You guys,
yep.
so it seems, right, so there's Envoy, we were talking about Envoy, Istio. It seems like they're almost competing design patterns, especially with Kubernetes, where you get the round robin between kind of your services by default. Have you used it with Envoy sidecars? Is there added benefit? Does it negate some of the features? What do you see with kind of the service mesh? Or are you like ideally replacing that or
The question is, what's NAT's relationship with Envoy? Is that fair? Or, are we competing? Yeah, we really see it as an and story. So there's no reason Envoy can't actually use NATS under the covers to do a lot of the work. So we've started looking at that. I know Wally's looked a little bit about what it would take to plug NATS into Envoy. So yeah, we're looking into that. But I don't necessarily see it as competing head to head. I mean, it's an and story, not necessarily an or.
work with Envoy sidecar, right? Which is like TCP. If you're actually having Envoy sidecar, it should still be able to talk to the NATS cluster and everything should kind of work the same. You get mutual TLS automatically, right?
Yeah, you might have some issues with TLS. So NATS, by default, opens up a connection with TCP. And then it does it gets a little bit of metadata from the server, giving it some information. Do I need to upgrade to TLS? This is something we know can cause problems in some environments. So we'll look at that, but
Well, if you had to disable at NATS, but let Envoy, right, do its mutual TLS thing between all the services,
okay.
theoretically,
Theoretically, it should work. Personally, I haven't tried it, but if you try it, let us know, please.
So
Sure.
Yeah, I don't know if one potential is going to be put out there with the sort of partition-aware routing from the Envoy side of things. So if you have, you've got your NAS cluster, you've got these subjects are partitioned here, you know where the data is within the cluster. You could potentially optimize routing from Envoy.
Okay. Okay, yeah, that's a great suggestion. Use Envoy to potentially optimize routing based on where partition data is in the cluster. That would be great with NAT streaming, actually. There was another question? Oh, yes? No, no worries.
Oh, actually, you mentioned that the messaging is related to the NAT server itself. An example was like Marshall JSON. Can you use binary?
Oh, absolutely. By default, NATS is payload agnostic, and the APIs, the basic APIs, just take a series of bytes. In the example here, Wally's marshaling some JSON to just easily pass fields. In NAT streaming, we use protobuf over core NATs. So yeah, the NATS, it's payload agnostic. You can send whatever you want.
Do you have to use, like, does the client have to use protobuf for the streaming? Or internally, NAT streaming uses protobuf?
Yeah, the question was, does the NAT streaming client, or do you have to use protobuf to use streaming? That's under the hood in the NAT streaming clients. So we do that for you.
Is there, as far as if you had to set some binary, what's the limit, the amount of data you can send at a time?
Okay, so what's the maximum message size? By default, in the NAT server, it's a megabyte, but it's configurable. So you can make it as big as you think you can handle, or by policy, you might want to lower it. And when that happens, when you send a message that's too big for the server, because of its policy, you actually get an asynchronous error back saying you've had a publish exception. So it lets the client know too. Sure.
In terms of distributed tracing, do we have an integration with open tracing formats, or let's say an microservice A wants to talk to me and to NATS, right? So they want to send the V3 headers in terms of the spans and the trace ID from service A to service B. They communicate using open tracing format. So does NAT have plan to support that, or does NAT support already?
Okay, the question is, does NAT support open tracing? Or are there plans to support open tracing? We've looked at this, and one of the things we're going to do is provide a reference architecture. It's in our near-term plans on how to use open tracing or one of the open tracing projects with NATS. But NATS, core NATS, does not have the concept of headers. So it's very hard to stick a unique ID in without doing something with enveloping the payload. So to that end, we'll provide a reference architecture on how to do it, and then users can choose to do this in their applications. One of the really cool things that you can do though is, remember when I said you can just subscribe to everything in NATS if you use that wildcard? So what you can do is have a client that subscribes to all tracing data, or subscribes to everything, and that's actually not interfering with your clients when they're tracing, but it's grabbing that tracing data from the NAT server as a separate client, which offloads a lot of that processing.
We built an Elixir client.
Wow.
Another Elixir client to do distributed tracing. So we add our headers and that JSON solution. And we've done some instrumentation around it as well. It's client level. But the idea of this, the single service, everything is pretty interesting as well.
Any other questions?
So,
You good, Wally?
Yeah. So the repo is there. If you have any questions, just we'll be at the Synadia booth. So if you want to continue discussing some of the new features on the server has evolved a lot this year, and it is there are very, very cool features for the multi-tenancy, more graceful shutdown modes from the server, a lot of security. Went into this release and have a new, as part of the Synadia team, we have a new service called the NGS that we're also, we can talk about it later. Okay, so that's it.
So thank you very much, everyone. And we're actually having NATS party tonight. So if you're interested, swing by the Synadia booth. What are we, Southeast 45? But yeah, swing by and we'll give you a wristband. Southeast 45, right? Yeah. I should know.
When you walk in, it's like 2 o'clock. What company is it?
Synadia. Yep.
It's right near Blue.
All right. Thank you, everyone.
Thank you.